All right, thank you. I'm going to be talking about YARA. It's one of my personal favorite blue teaming tools. It's pretty simple, so it's going to be a pretty short and sweet presentation, but hopefully it's something you could add to your own blue teaming toolkit. So who am I? I do Kubernetes and Linux on CCDC, and I also do red teaming here. Here's a picture of my dog, some pictures from the CCDC trip. So what is YARA? At its core, YARA is a text pattern matching tool. It's an open source tool developed by VirusTotal, and it's mainly aimed at malware researchers, but it can be used for anything really. And it works by you write custom rules in files, and it's going to match specific signatures or patterns in files or processes, and it gets to do scans on files and also in memory. So the main component of YARA is the YARA rules. So we're going to take a couple minutes to take a look at them, how they work, kind of walk you through that. So here's one for, this is a pretty industry standard test file that's used to evaluate new like antiviruses, things like that. So at the top of the file, we're going to have first the rule name. So for this one, it's multi-icar, and then a bunch of random stuff. This one was written, we can see in the metadata by Elastic Security back in 2021. It's just a severity of 1. It's not severe at all. This is really just a test. And it gives us some more information about where we could use this scan. It's for both x86 and ARM64 architectures, and we could do it in file or memory on multiple OSs. And then under the strings, this is going to be what it's actually looking for in your scan. So for this one, it's going to be this string of characters, and it's going to be a full ASCII word. And then the final section we have is the condition, so it tells which one to match. For this one, it's a very simple condition. It's going to be all of our strings, which is just that one. We could see in later examples there could be ones where you have multiple strings you want to match, and you can do a lot playing around with that. Here's a more advanced one. This is for the Linux ransomware family Hello Kitty. This one was also written by Elastic Security. By Elastic Security. This one has a severity of 100. It is a serious threat if it's seen in the wild, and it has 3 different strings: file locked, and then a PID, an error encrypt, and this last A3 string. And we have a condition where it says if you match 2 of them, then that's going to trigger detection. So the YARA workflow, how does YARA really work? How are you going to use it? So a typical YARA workflow, it begins by identifying common text and hex patterns in a family of malware samples. That's how you're going to be able to write the rule once you identify what's common in all of these samples, what can we use to detect it. We're using those patterns, we're going to create a YARA rules file. It's going to be looks kind of like that. And then you can compile a set of rules to one file. That's optional, but I recommend it, and I'll go into why in the next slide. Then we're going to run scans mainly using our YARA CLI tool, but there's other tools that you can integrate with it. And then you're going to want to tune your rule set. You don't want a lot of false detections, so over time, you're going to notice maybe this rule is detecting a lot more than it should. We don't want that, so we're going to kind of tune it, adjust our conditions, things like that. Compiling YARA rules, the command to do is YARA-C and then the file name and the output file name. So an example of this would be this command we have here. This would match any rule in our set that starts with Linux or multi, and it would compile it to a file called op.yara rules compiled.linux. This has a couple benefits. Mainly, it's going to give you a lot better performance. Scans are going to go a lot quicker, which is important when you're doing large scans of many rules. And like kind of side effect, but something that really helps with is you're going to ensure there's no syntax error in your rules, which is going to be a big help for later on. And here's what a manual scan would look like. We have a couple options here. This is the one that I like to use. So the TAC-W, that's going to help you suppress warnings, which is helpful. You're going to have less output then. TAC-R is very important. That's going to make it recursive. So it's going to say you wanted to scan /var. It's not going to just do what's in /var. It's going to go into all of its subdirectories and scan all the files there. And then the TAC-C and then the file name after that. So TAC-C op.yara rules compiled.linux is going to tell it to use the compiled rules file. That way we get the performance boost. And then the final option is the directory to scan. So that's really just telling it where do we want to start our scan. And then we're going to see this. I prepared a little demo after this so we could take a look at how it works. One thing that I did find, I want to do some more research into this summer, but they do have by VirusTotal, they developed a YARA Python library, which lets you integrate your YARA rules and detection into Python scripts. You can do things like making a custom-made automatic threat detection script using the capabilities of YARA. So this is something you could definitely look into if you want to build a cool blue team tool for your competitions. Catching sliver with YARA. This is what we did actually, not this year, but the year before at CCDC Regionals. We're able to catch the sliver C2 using YARA rules. So it definitely comes in handy. If anyone doesn't know, Sliver is an open source command and control framework. It was developed at Bishop Fox, and it's kind of an alternative to Cobalt Strike. It's got a lot of different methods it could use to communicate, like HTTP, HTTPS, MTLS, and DNS. And it's commonly used by both red teams and real threat actors in the wild. So here's a rule that you could use to detect it. So we see here it's got a severity of 100, and you could scan both both files and in memory on multiple OSs for it. So the strings it's looking for, this is methods that are going to be called and function calls that you're going to see in the actual binary from the code. So if it sees at least 2 of these based on the condition, it's going to trigger a detection. You know, okay, that's Sliver. You need to take a look at that. Similarly, this is another one with some different strings. The first string is the GitHub link for part of the Sliver tool. So if you see that, you know, okay, that's Sliver. And then we also have the B1 to B5 are some more function calls that are used a lot. So in the condition, this one's kind of interesting. It shows you how you could kind of play around with the condition. There's a lot of things you can do with it. It's going to say that it's going to trigger a detection if you have one of the A strings, which is the GitHub link, or if you have all of the B function calls. Either of those will trigger it. And then finally, one thing I didn't really touch on yet, so I wanted to include this example. This is one only for Windows, but this is actually, you could do not just ASCII strings, but you could also do hexadecimal strings for your detections. So this is an example for Windows doing hexadecimals. If both of those are present, that's going to trigger a detection because these are hex strings commonly found in the Sliver malware implant. Yeah, so I just prepared a quick little demo to show. Wrote a Docker container, uploaded some malicious files to it, and we could see Sliver kind of in action. Yeah. Yeah, so here we have a file. This is from the Elastic Securities Protections Artifacts repo. It's an amazing repo. We have a lot of rules, and it's categorized really nice by Windows, Linux, and multi, and Mac OS. So this is definitely a good starting point if you want to check out YARA. Working just with this repo, you are going to catch a lot of stuff with just this. So we're going to run our command to compile the rules to the opt-yara rules compile.linux. And let me just change directories real quick to /root. So I found yesterday when I was prepping my demo, if you run just on the regular whole file system in this container, it was giving me some issues with especially /proc and /dev. So to avoid that, I wrote this quick little bash script where we're going to scan every other directory recursively other than that, starting at root. And it's going to just tell us what directory it's scanning, and then it's going to run the scan to see if we have anything. So yeah. So we can see right away it's detecting some stuff in bar and user. And then we have a lot of stuff. This is kind of one interesting thing about YARA is we're going to notice there's a lot of detections in our opt directory. That's because that's where the actual rules are. So because the rules contain the string you're looking for, they're all going to trigger it even though it's not actually there. So that's something to be aware of. But we do see user bin demo. It's detecting a generic Linux threat as well as 2 rules triggering Sliver. So that's something we're going to want to look into. That is actually where I put the Sliver binary. And we also see another hidden file that's from Metasploit I put in bartemp.evil as hidden file. So not just Sliver, you can get all sorts of implants with that. And then one final thing I kind of added in was bin is also going off because of that demo file, home.test.txt. This is a custom rule I wrote called benign. So if we cat that file, we can see this isn't actually malware. This is showing how you could use it for more things. I just wrote a quick little YARA file. I could pull it up right after this to show I wanted something that would detect on the RITSEC flag format around test 123. So I wrote a custom rule showing. Oh, yep. Mm-hmm. That is definitely. So that's something you're going to want to be aware of. Know where you have your YARA rules. And yeah, so if you see something that looks like a YARA rule, but maybe it's in bar temp when you keep all yours in opt rules, look at that. That's probably not your YARA rule. So yeah, good question. And I'm just going to go back to the opt rules so I could show you the custom rule I wrote to detect this. That's kind of showing YARA. It's not just for malware detection. You can write all sorts of stuff in it just to detect different file types, different text patterns. Oh. Yep. So here's the benign rule. So we just have the first string is the RITSEC flag. That's a regular expression for the RS wrapping the text, and then the second string is the test string I wanted to do, test 123. So for this one, I just wrote that the condition is going to be all of them. So if both of those conditions are matched, it's going to trigger detection. So that's a really simple example of a nice basic YARA rule you could write. And yeah, you could write your own easily. You could use, like I said, the protections artifacts from Elastic Security is a great example. And hopefully this is a nice little tool you could add to your blue teaming toolkit. Try it out your next red versus blue comp. And yeah, that's all I got. Anyone have any questions?